came up with this equation. This equation was born out of the the ideal gas law and Carnot's efficiency equation. Forgot to put the minus here. I realized with a compressed air engine, it would be like the density of the gas molecules and the space between them would be no different if you used heat to pressurize the gas from to that temperature. And this is here. I rearranged it. We are assuming that we pressure ambient, temperature ambient, and pressure high. It will spit out a temperature low that it would be ambient at if instead it heated up to get the high pressure. Then from there we go from this equation, but which T ambient, that's the temperature that the compressed air is currently at before going through the compressed air engine. Then it's either T low or TB. TB would be the boiling temperature at the ambient pressure, or if T low is higher than TB, or the gas boiling temperature, then you'll use T low instead. From here, you basically, I think this is T ambient. Then you get T low out, which in a perfectly adiabatic system, meaning no heat transfer, this would be the temperature you would get. A gas is different from a hydraulic fluid. I came up with a hypothesis to try to explain why gases are compressed and heated. They heat up, and when they decompress, they cool. The hypothesis is that, according to what I've read, that as gas molecules expand, the molecular forces responsible for say when it's cooler and for forming the liquid and solids is still working at a gas state. It's just the gas molecules are going so fast they are able to not be restrained, but when they expand, potential energy goes in between that space, and it slows down the kinetic speed of the atoms or molecules. This is my explanation, or at least my hypothesis. And for say and also I can explain why certain gases, like for hydrogen, heat up when they are just say if they don't go through the engine and just go through, then if you just release it to the open air, they'll actually heat up, because hypothetically or hypothesis speaking, the heat when they spread out, the heat energy they want to absorb in their bond, through the latent energy stored is less compared to the friction, the energy lost due to friction. Which, not energy lost, the friction, but the heat energy generated from friction forces. And also, this equation assumes that you're doing work, that it's driving an engine. There's another equation dealing with just open expansion. And there is even another equation that requires a specific heat ratio for a specific gas. This equation will work for any gas, and also it's only for decompression through the engine, not compression. Because because those were the assumptions I made using this equation.